Okay, well, the waiting room is temporarily all empty, so I think at this point, maybe we'll just go ahead and get started here. Welcome everyone to the FPP session on research transparency and data management. It's great to have with us Sebastian Karcher. He is Research Assistant Professor in Political Science and Associate Director of the Qualitative Data Repository. I'll let him explain a little bit about what QDR is and does to the extent that he wants, but it's a great resource for you. They've got a lot of things up there. It is indeed a repository, but they've got all kinds of other resources that are going to be useful for you, kind of walking you through developing a data management plan and so forth. There are also some other resources at the university that we can maybe talk about a little bit at the end. So feel free to put any questions you have in the chat when there's an appropriate time during the course of the presentation. We can take some questions. Also feel free to unmute yourself and simply ask your question as well. I think we've got a group that's small enough that we can manage things that way. So let me say that at the beginning, before I forget or don't get a chance later on, although many of you FPP participants are enrolled in the program with a view to earning your certificate in university teaching, and if you've been checking emails, you know that those seminars are flying fast and thick at this time of year. But the goal of the Future Professoriate program is to address all questions relevant to your preparation for faculty careers, and obviously research is a big part of that as well. So we've got today's program on research transparency and data management, and then we'll have another program coming up on October 30th, which is on managing and enhancing your research reputation and visibility. That's going to be with Emily Hart from the library. You're definitely going to want to catch that, and I'll be having some communication coming out soon about that and registration link and so forth. Okay, we've only got an hour today, so I won't take any more of Sebastian's time. If you want to take it away, Sebastian.
Hi. Thank you, Glenn. Thanks for having me. Thanks, everyone, for joining. So my name is Sebastian Karcher. The Qualitative Data Repository is kind of a unique place on campus. We sit in the Maxwell School, but we are a data repository, which means we accept data from around the world, really. I think we're at 5 continents now. And what QDR does, it is a qualitative data repository, so we focus on qualitative data. A lot of it is interviews, interview transcripts, focus group transcripts, but also scans people take in the archives. We've got some videos and movie clips, and we've got some maps, some images of old patents, so wide range of data. I'm going to be talking about research transparency and data management in very broad terms, though. I'll draw on my expertise. So some of the examples are going to be from qualitative social science, but I hope to, I try to write this presentation and this workshop so that it's useful for you, whether you are in political science like me, whether you're in education psychology or in physics, astronomy. I'll probably be better answering the question if you do something social sciencey, though, I'll be honest. So to motivate this, why do we care about research transparency? And this is a big movement that many of you will have heard about across really the sciences. And one reason we care about this is to be transparent about your research is really core to being a good researcher. One thing that makes science, that makes it different from other disciplines, from other ways of gaining knowledge, like journalism, say, is that science follows specific rules. What makes science is we follow specific procedures. They differ from a little bit between disciplines, but we follow those. And that's foundational. And so being transparent about how you follow those rules, being transparent about your research is really key for being a good researcher. Being transparent, and I'll say a little bit more about what I mean by being transparent, but it's also being a good colleague. It allows others to look more closely what you've done and perhaps find errors in it or not, which would be preferable, but also to build on your work, right? So you may share some of your data and someone else may reuse that data, perhaps even in a different disciplines to find something completely different. It's also part of being a good citizen. A lot of our science is directly or indirectly publicly funded, right? Where we don't receive money directly from the government, we receive money as a subsidies. Syracuse is tax exempt, for example. And so we have a responsibility to give back. And as we are transparent, as we share more of our work, of our data, of our code, of our materials, we give back more to the public that helps us do our research. And we are more impactful in our science. We reach further people with what we do, which is, I imagine, why many of you are in whichever field you're in. And finally, there are some sticks involved. Scientific funders like the National Science Foundation, the National Institute of Health, etc., expect you increasingly to be transparent, not just to publish, but also to show your data, show your code. Similarly, an increasing number of publishers and journals have that as a requirement for publication. So when I talk about research transparency, I talk about three things. This is adapted from a definition by the American Political Science Association. I can't escape my roots, but it's really quite broadly applicable. One is data access. So as you collect data, you share that data with other people so that they can look at, okay, this is how the information, the conclusions of your study are based on looks like, and they can scrutinize it, they can build upon it. It's also the analysis. So how did you analyze your data? For quantitative data, that will often be computer code, right? So if you analyze traditional quantitative data, you may have R, Stata, SPSS, Python, whatever script that you use to arrive at the figures and tables in your study. And that shows your analysis. If you do more qualitative research, that may just be a close description of how did you, say, code interviews to arrive at certain concepts? How did you look at archival evidence to come to certain conclusions, etc. And then finally, what I call production transparency is how did you actually produce your data, right? A quantitative data set or a qualitative data set, they don't just come into the world. You may have instruments involved in creating the data. They may be very simple or they may be very complicated, like an electron microscope or an MRI. You may have surveys, which are the instruments that as social scientists often work with involved, which have a lot of questions related to what do you ask, who do you ask, how do you make sure you reach the people that you want to ask. So these are the three modes of transparency. The pointy bracket actually should point to data access and analysis. And you hear that in a lot of talks about open science now. You talk about reproducibility. And reproducibility really means that you give the people enough to recreate the figures and tables in your paper. And so if you give your readers the data that you use and the computer code that you use, your study and that runs on other people's computers, which those of you who do that type of work know is not always guaranteed, then your study is considered reproducible. And that's a goal and very worthwhile in terms of making your research more transparent, because then people can, tweak a little thing and check, does this still hold if I build a robustness test in my analysis, those sorts of things. Okay, so this is why we should care about these things. But what I want to talk about is a little bit of the building blocks on how we make this happen, and particular the data sharing part. So the first part of our research transparency trifecta. I'll talk a little bit about what we mean by when we talk about data management and what is some good advice for data management. I'll talk some about a device that is called data management plans that those of you who have applied to NSF funding will already be familiar with. A lot of funders are requiring these now. They're a good idea whether you're applying for funding or not. I'll briefly touch on IRBs, so institutional review boards that supervise human subject research at SU and any US university, and how they relate to data and data sharing. I know that doesn't apply to everyone here, so I'll do that pretty quickly. And then I'll talk a little bit about how data sharing actually looks at in practice, where, how, when, those sorts of things. So research data management, this is a definition from colleagues at Edinburgh who were very early on in establishing a division at the library dedicated to research data and research data management. And they describe it as caring for, facilitating access to, preserving and adding value to research data throughout its life cycle. There's a lot going on, but what I really like about this is this idea of caring, right? If you don't care and nurture your data, both in terms of keeping it safe, but also keeping it orderly and well documented, it withers away. But if you do that, you add value, you make your data more valuable than it is in its raw form. And you don't just do this one, but you do this throughout your research process, throughout what they call the life cycle. And a data management plan is essentially a document that you typically start drafting fairly early on in your research, where you describe exactly how you're going to do that. From the start, from, you know, how am I going to conceptualize and collect the data, to the end, how am I going to share it with all the intermediate steps included. So why is this so important? Well, you're graduate students, so a lot of you will be involved in data collection right now, and you know that it is expensive. In some cases, literally expensive. You use survey companies, expensive equipment, etc. But even if you do everything yourself, it's still your time, and your time is very valuable. The data that you collect, they underpin your published findings, and you want that data to be robust and well organized so that your findings are robust and well organized. You really, really don't want to lose your data, certainly not in the middle of your dissertation writing, but really not ever. You want to be able to produce the data when that's required, be that for an audit by your IRB or by your funder, or be it because it's a requirement for publication in journals. But you also want to manage your data in a way that protects it to be in agreement with ethical codes and laws. So you may need to shield some information from coming into the public, such as identities of research participants. One of the things that I want to really stress in the first half of what I'm going to be talking about is that the biggest beneficiary of all of this is really you. I took a long time for my dissertation. I hope most of you will take less time for your dissertation, but even if you only take 4 or 5 years, that does end up being quite some time, and you do forget things. And being well organized, having things maybe written down in a little bit more detail than you think at the moment is necessary. Being a little bit more meticulous in where and how you name and store things will pay off many, many times later on, as you're stressed and have so many things going on at once and need to finish that dissertation and have that one piece of information that you know exists, but where did you put it? Being well organized, so having your data well managed, is incredibly valuable later on at what is going to be both a stressful and a critical time for many of you. So here are some of the things to think about. The legal, ethical, and other institutions involved as you collect data, right? I mentioned privacy rights. In other fields, there may be patent rights that may be involved, or other intellectual property. There may be safety laws to be observed depending on the equipment you work with, those sorts of things. Are there specific institutional policies you should follow? So for example, SU has a policy for what sort of data can and cannot go on Dropbox. SU has a policy for intellectual property that you produce while you're at SU, those sorts of things. Are there going to be multiple people involved in your project? Well, you may say, no, I'm a graduate student. Of course, it's just me, but often that's not the case. At a minimum, there's your advisor, and in a good case, your entire committee that may get involved in maybe helping you look at the data, make sense of it, those sorts of things. But you may also hire people to help you, either now or once you're at a junior faculty position. That may be people who help you in the lab, that may be people who transcribe data, that may be people who translate for you. So very likely by the time you finish your dissertation and publish the work based on it, more than just you will have been involved in it. And you need to think about how these people get access to the relevant data. Are there additional precautions? Is there training involved that they need? Those sorts of things. The more complicated your team gets, right, the larger the number of people involved is, the more important it is to actually occasionally review those your data management, the agreements, what did we agree on, what we do with this type of information, those sorts of things. If it's just 2 of you, you probably don't have to regularly review. If there's 8 people in your team, you probably do. As you plan, think about that the fact that some of the stuff that you may want to do may cost money. If you want to store tons of data on a cloud service, right? You have 2 or 10 gigabyte are free, but if you want to put 100 gigabytes of data on Dropbox or so, you need to make sure that that's either covered by the university or that you have the funds to pay for it. If you need tools, ranging from complex tools to a digital recorder, think about costing those and make sure you have the budget for that or write it into a grant. So starting with actually doing things. And this is one of the simplest and, in my opinion, most impactful things that I'm going to tell you about. Start with very simple rules as you think about organizing your proposal. And file names is perhaps the simplest things that you can do, and is a thing that is going to pay off hugely. Right, you see those 2 tongue-in-cheek examples here, but they're not that far away from the truth. If you have a good convention about how you organize your files, and I would say that actually means both your folder structure and the files, that will help you enormously. My recommendation is always set up a folder structure even before you put files in there. Have kind of this, think about how would my project be set up? What sorts of different data would I have? And how do I put them in different folders? And there's no right here, right? This just needs to be helpful and consistent to be right. So this can be, for example, your folders could be for different research sites if you do field work. And then within those sites, sorted by data type, maybe, you have research site A, and then you take some samples from there, and then you maybe take some pictures from there. Or it may be by month, if you just kind of do similar things, but you do them over and over again. You just have 1 folder per month in which you then record your measurements, etc. And then for the file itself, the same thing should have a similar file name. Again, make this something that's useful for you, no rights or wrong. We often recommend, and that's almost always going to be a good choice, to include today's date or the date the file was created in year, month, date format as part of the file name, and make that consistently. Year, month, date means that if you have multiple versions of the same file, your computer easily knows how to sort that. Whereas if you do the month, day, year that we do in the US, that will create terrible confusion for the computer. The second big thing that I want to what I want to impress on you is the importance of documentation. We often write documentation only towards the end of our project, and that's a big mistake because we have lots of other things to do. We want our publication out, etc. But also we'll have forgotten lots of things. The nice writing good documentation, and I'll give some examples, enables you to understand your data when you return to it. And that's going back to that question, is you are really the first reuser of your own data, future you. It also helps others understand it, both within your team, but then also later as you want to share that data. It helps you avoid incorrect use or misinterpretation. Again, it's super helpful within your team. I've started working with more and more GAs. Having good documents that I can point them to is incredibly valuable because they're self-explanatory and I don't have to spend 2 hours with every new GA to orient them on a project. I can just say, here are our docs, read through them, let me know if you have any question. It's super helpful. And that also applies once you share the data, right? The better documented it is, the better you shield yourself against people misunderstanding or misrepresenting your research. As you think about documentation, the key question is really, if this were the first time you arrived at your data, what would you need to know to make sense of it? This isn't, you know, you don't have to explain your physics data to a political scientist, so you can assume disciplinary knowledge, obviously, but don't assume that that person knows kind of the little tweaks that you did in a lab to get something to work, or those sorts of things. Couple of things, and this really depends on the nature of your research, but here are kind of things that I think about in capturing documentation. Broad contextual information about your project and data. You typically have that. You'll have written that in a grant application, etc., in your dissertation prospectus. Data collection methodology and processes. We often write these in publication, but we typically want to have them written down in more detail. Exactly how did you sample? How did you select things? How did you proceed? What manuals did you use? What instructions did you follow? Those sorts of things. What sorts of files did you collect, right? What type of file types, where are they stored? Those sorts of things. If you collect variables, make sure they're well documented somewhere. What does the variable RGB13 mean? Is that, I don't know, probably has something to do with color, but you want to have some sort of codebook and you want to create that codebook as you go along. And if you do research with data that's somehow protected, be it because of human participants or be it because of intellectual property rights, make sure you document what you promised to the people you got the data from or you interviewed to get the data. So confidentiality, use conditions that can even apply if you get data from commercial databases. They may have licenses. So document the conditions under which you can use the data. Do this early on, right? Again, if if you start writing documentation towards the end of your research process, A, they don't help you re-understanding the data, and B, you'll have forgotten a lot of the things that are crucial to get those small details that make all the difference, right? And so just to give you some sense, and this is from some data that we worked with at QDR, so this is particular to our type of data. But one of the things that I want to show with this is this doesn't need to be complicated. Spreadsheets are a great solution for organizing and describing things. Use tools that you're familiar and comfortable with. Those tools can just be Google Sheets or Excel, but they can also be dedicated tools like DevonThink, so more complicated node manager. Roam is something that I see more and more people using. There's lots of tools that you can choose. Again, no right or wrong. The key thing is use something that allows you to organize the data in a way that's structured and helpful for you. So here, an example, it's a fun project where an author in 2016 looked at different ways in which the presidential candidates were displayed in a dehumanized way. So often as monsters. So you see monstrous, there's Frankenstein, Trump monsters. The same side of descriptions appear in the Clinton text for tab for Hillary Clinton. And then so she captured the title, where it was published, if possible, the author, when it was published, then the original URL, and further on in the spreadsheet, we then also captured the Internet Archive URL. So to make sure that there's a record of this, even if the website no longer exists. So very simple, but basic information. What is it? When is it? Where can I find it? Where did I get it from? Who published it? Those sorts of things. If you work with specific files, be it data files, we have a lot of files that are interview transcripts, those sorts of things. Often useful to include documentation in the file proper. So if you do interviews, just have some basic information at the top of that interview. If you do statistical data, you can often include variable attributes in the data file themselves. So you have, say, the question tag of a survey, those sorts of things included with the data itself. If you use a spreadsheet, use good labels for the worksheet, right? If you go back here, it's actually pretty clear what you would expect under each of those sheets. Don't just go with the default sheet 1, 2, 3, 4, 5. So here is an example from QDR, a very simple template. Raul Madrid is the interviewer. Felipe Quispe, this was an on-the-record interview, so no need for confidentiality, is the person he interviewed. Next row describes what he is. By the way, those of you who follow politics, he was still running in the election that just happened this weekend in Bolivia, got 2% or so. And where did that interview happen? When did that interview happen? And then a consistent structure on how question and answer are separated. In this case, bold and normal text, but you can do any sort of thing. You can just use some sort of clear speaker text, as long as it's the same across all your documents. Something that you'll hear a fair amount about, especially, and is often a requirement for writing data management plans, is to talk about data metadata. Metadata is really essentially a fancy word for documentation, but documentation that follows certain structures or conventions. So if you think about metadata that you're familiar with, as you write bibliographies, the different components of that bibliography, right? Author, title, date, publisher, volume, URL, DOI, those are different components of metadata, and they are highly structured. Search engines actually, like Google, create their own metadata by putting that web into more understandable structured categories that then allow Google to give you understandable data. There often are disciplinary standards for metadata within your discipline, and they are meant to give people the relevant type of information to understand data better, right? And you can understand why that's disciplinary, because the data that I would need to know about, say, a sequenced gene from an animal is very different than the type of data I would need to know about a public opinion survey or about astronomic telescope observation. So the metadata will look very different, and there's no reason to use the same metadata. And so if you work in a specific field, it's a good idea to become familiar with what are the 2 or 3, or in some cases just 1 metadata standards that most people work with. You'll recall one of the things that I mentioned about data management being important is you really don't want to lose your data. And I hope all of you are doing this, but in case there's 1 or 2 people who aren't, I'll put up some horror scenarios, right? And so data can get lost in very spectacular ways. But data can also get lost in very mundane ways with a hard disk problem on your computer, and you can't open your hard disk anymore. Especially the modern solid state hard disks are really, really difficult to get data off again when they're broken. So protect yourself against this. So how? There are, I like to think of this as two rules of thumb that help you do this. Rule number one is for every important file, have 3 versions in 2 locations. 2 locations are pretty straightforward. If something physical happens, right, your house gets broken into, natural disaster, those sorts of things, you don't want all your data in that one location. 3 versions, A, more versions are safer, but B, some data may get corrupted, and sometimes you can still open the file, but then you don't know which of my 2 files is the right one. If you have 3 files, you can kind of go by the majority. You still have 2 correct files. Those are right. So that comes, that's a concept from information science. The second rule is make sure you have backups that are regular, automatic, and incremental. Regular means at least daily. Towards the end of my dissertation, especially for my actual dissertation draft, I had an hourly automated backup. Automatic is crucial because you don't want to do some complicated thing every hour. And you also don't want to rely on you remembering to do your backup. So set up something that works without you having to remember something, because otherwise Murphy's Law has it that you will need your backup exactly when you forgot to take it. And then incremental, that's what those of you who use a Mac will be familiar with as time machine, right? You want to go back to individual times over individual points in time. And the nice thing about this is this isn't hard to do. This may sound like a super complicated industrial safety setup, but what this looks like in practice is you have an external hard disk and you have some sort of cloud service, whether it's a university server or Dropbox, OneDrive, etc. And your local computer, that's your three versions. There are 2 locations, right? External hard disk and computer location 1, cloud server location 2. Those backups happen automatically, right? Your Dropbox, OneDrive sync, your external hard drive, you should have an automated program that takes a backup once a day, and both a good file syncing service and your backup software will work incrementally in the way I described. Importantly, occasionally check that you are actually going to be able to open your backups. If you want to Google, there's a fun story about how Pixar almost lost the entire movie of Toy Story 2 because their backups weren't working. So happens to the best of us. Lots of things that can go wrong, right? So don't think about a specific scenario that could happen to you, which is why you want to have a robust backup strategy. I've mentioned cloud services. Generally, a huge proponent of using one of them for your data and information. You do need to be a little bit careful if you have sensitive data, so particular data that contains personal information of research participants. You may need to encrypt. The university has IT services, often have really good servers that you can use that are particularly secure and vetted by the university, and so the IRB knows about them, those sorts of things. There are also dedicated cloud providers otherwise that are so-called zero knowledge. So that wouldn't be your Dropbox on Google Drive, but those are services that will encrypt your data on your first computer, store it encrypted on their servers so they can't actually access it, and it decrypts when you resync it to your second computer. Especially if you have large amounts of data, some of this will cost money, so you need to make sure you've budgeted for this, right? Your 10 gigabyte Dropbox are free, your 100 gigabyte Dropbox are not free. So as someone who preserves data for a living. I don't like to talk about data destruction, but sometimes it's necessary. That could be because you've promised it for some reason. Some of your data are just so sensitive that they need to be destroyed. It could be because you're passing on equipment, right? You got a fancy new computer and you want to pass on your old one to your little brother or your little brother's friend. You want to make sure that you don't just format the hard disk, because you can lose an off-the-shelf program and still read files. Everything that you see with the red cross there is technically deleted from the hard disk, but you can still read the entire file with standard software. So you need to make sure that you delete the data properly. There's free software for that. That's often called folder or file shredding software. If you have super, super sensitive data, there's official government recommendations to incinerate and pulverize your hard disk to destroy it. So you get to have fun with that. Data management plans. So very brief, but these have been around for quite some time. They came about in the 60s and 70s, so pre-computer era, as you had these complex engineering problems with lots of moving parts, aerospace, space travel, those sorts of things. And it was really critical that you could look up any information that you needed relatively quickly, especially because you didn't have a computer to look it up. In the early 2000s, people were like, we now have all this new data and people are collecting it digitally and there's so much more of it. And we really should look back at these practices and figure out to make them work for us. And so in the UK, the funders, all the government funding organizations, very early on decided, okay, everyone who applies for one of our grants needs to write one of those data management plans. In the US, the National Science Foundation has been requiring them since 2011. In the EU, it's required as part of their big funding scheme. So increasingly a requirement across different funders. Data Management Plan, or DMP, briefly describes what data will be collected, how it will be organized, how it will be documented, how it will be stored and protected during the research, how it will be stored and protected after project completion, and what data will be shared when and how. Thankfully, you don't have to remember all of this. There's actually an app that helps you through this. The one that you are likely going to use is called DMP Tool. You can log into it through Syracuse University. And then you see here on the left of the screen, you can actually select a specific funder, and they have slightly different requirements for their data management plan, and then the template for that funder. And then they don't write the plan for you. It's not that good of a tool. They give you little text boxes to write the different components of your plan. And you write into them, and then they have the original guidance from NSF, and then they wrote some additional guidance that kind of help you to think through some of the issues that are relevant for this particular subpart. NSF, incidentally, strongly recommends you use this tool. I would also recommend it. It's really helpful, especially if you've never written one of these, to give you a little bit more structure to write with. One thing to remember if you do human participant research is that your data management plan and your IRB application actually cover a lot of similar ground, right? What do you do with your data? Where do you store your data? How do you keep your data safe? They're also both requirements, sometimes even both federal requirements, right? IRBs are an extension of the federal government implemented by Syracuse University and any other research university in the US. DMPs are by the NSF. So essentially, you're making promises to the federal government in both of them. And it's absolutely essential that you make the same promises, right? You can't say in your data management plan, I'll share my data, and in your IRB application, I'll destroy my data. And if you think that will never happen, I can absolutely tell you it happens all the time. So be mindful and careful with this. there's a lot of resources that can help you with this, right? You want to consult with your IRB as you write your data management plan so that the two are aligned. Your IT department at SU, that's typically within your school or college, will be kind of the first level provider. If you work with partner organizations, so be it whether you work with an NGO or an international organization in your fieldwork, or whether you work with a private company in their lab, you want to be very clear about what rules and expectations are. If you want to share your data, and we'll talk about this in a bit, in a data repository, do talk to the repository with which you want to share to make sure that it's a good fit so that they know what to expect. Maybe there are costs involved. And finally, often a good idea to talk to your local data librarian. So the library has data services as you. They're very experienced across a wide range of disciplines. I have the URL and the link here, the email here, and I'll send those slides to Glenn so he can share them with all of you later on. As you write DMPs for a grant, I also want you to think about them strategically, right? You write these principally for your funder, and NSF in particular is really keen on data sharing. So make sure that you are very clear about how are you going to share your data, what data are you sharing, what data can't you share, and especially for NSF, it's a good idea to be very specific about reasons specific data can't be shared, and not all data are shareable. The DMP will also be standard part of your grant package, so all your reviewers will read it. And so you should write that in a way that shows to the grant reviewers that you know what you're doing, right? It gives you another 2 pages, that's the length of an NSF DMP, to showcase your expertise in research methods and good practices. Don't waste that. And then the 2 things that we already talked about, use it as a document for your team to be able to refer people to. You may actually want to use a separate version of that that you put somewhere where people can add and comment on it, like a Google Doc or something, so that it's a kind of a living document and reflects your evolving practices. Because, you know, it's supposed to help you, and plans, even the best laid ones, change. And finally, your future self, right? You want to be able to refer back and say, oh, this is what I said I was going to do. I probably should do that because I thought really hard about this and I got all this advice. All right. I'm not seeing any question in the chat, so I'll do the last bit about sharing data. Cool. Emily, sorry, Emmy, go ahead. You can unmute yourself or you can just type it.
Oh, hi. Thanks, Dr. Karcher. This is a really excellent presentation. Thank you. It's very informative. I have a question. It's less about, you know, the sort of reasons for sharing that you went over, which are all very good, you know, in terms of doing research, and just more about a ethics sort of question. This has actually happened to me. Let's suppose, you know, you collect a lot of data and you do a lot of work on the data to get it into the format that you need to do your analysis. And it's taken a lot of effort and a lot of time. And, you know, let's say you have like a working paper or something, or you're intending to publish something, you do a presentation or someone finds out about your data and they ask you for it. You know, like, wow, that data is really neat. Can I have it? And I've said no. I mean, I feel like I'm a really nice person. You should see the political side I have on the lawn, but I don't know. It feels like after you've gone to all this effort to create this beautiful data set, and then somebody else wants it just to use it for their research, I don't know. Anyway,
yeah, it's a very important question. And so when I go through these reasons, this is actually, right, so this is, other people can chime in the chat while I'm talking. So what are some other reasons why you may want to share data, and what are some reasons not to share data? And, you know, the fact that you put a lot of work into it and you want to get the benefit of it is a perfectly valid reason. And there are some disciplinary differences in expectation. I would say you're at Maxwell, right? Yeah.
Yes.
In most of the social science, the expectation is that at a minimum, you get one publication out of your data before anyone expects you to share it. And that's a formal publication. So that's either a book or a journal article. That's not a conference paper or a working paper. And in some cases, you can justify maybe an extra year or two, although increasingly in social science journals, the expectation would be that at the minimum, the data you used for the analysis in a given paper needs to be shared on publication. But at that point, you at least got your first publication on it, and presumably also, you know, a running start on some subsequent publications. So that's kind of the disciplinary norm, and it's perfectly fine, and no one should begrudge you. Maybe people will begrudge you if you say no for data for unpublished research.
And the second part of my question was exactly that. Like, what's the most diplomatic way to say no and still be a good colleague, right? And
You don't say no. You say, "Oh, I'd be happy to share it once I've published on it."
that's great. Thank you.
All right. Some other reasons people can think of. We've talked a lot of why you would want to share data. So why might you not want to share your data? What Emmy mentioned is probably one of the biggest ones, but there may be other reasons. And you can unmute yourself, or you can type, whatever works for you.
Sebastian, while people are thinking of questions, just to kind of follow up on your recommendation to Emmy there. So is that something that you should maybe plan for, or can you plan for that to an extent? Like, you've got a data set, you want to get perhaps more than one publication out of it, and maybe a larger project, but then once you publish that one article, you're kind of obligated to publish the data that you used for that project. Are there ways that you can kind of build in techniques to kind of like sequester data, some of your data, so that you can kind of save it while still being ethical in terms of sharing the stuff that's been published?
Yeah, so I'm seeing the answers coming in very good. I'll pick those up in a minute, but that's also a great question from Glenn. So there's two parts where you can do things, right? So if you get NSF funding, there is an expectation that you share data at some point, but they typically give you time, and that depends on the project, the program officer, but that varies between 1 and 3 years after grant completion for publishing the data. So you can build an embargo into your data management plan, but that doesn't refer to the publication. A lot of journals will require you, as I said, to publish the data alongside the article. Some will even check whether your tables and figures are produced by the data and code that you submit. There is two things that you can do. One is go for the biggest bang contribution first, right? The most important, article at the highest prestige journal that you want to go to should probably be the first one you publish. That's also the journal most likely to have the strictest requirements on data sharing. And then getting scooped, quote unquote, is less of an issue. And remember, you still have a running start. You know the data best. You've already started to analyze it, even write the other paper. The other thing that you can do is what they require, and among journals, there's no exception to that, is just the data to produce the findings of that particular paper. So if you have a really rich data set, so I'm always thinking survey, right? You don't have to share the survey questions that you don't analyze in a particular paper. You only need to share the raw survey questions and answers from the survey that you did share. Yeah, so two really important other issues coming in, and they're somewhat related. Participant confidentiality is probably the second biggest reason not to share data. You can de-identify data, not always though, and it can be hard, and you may underestimate when data can be re-identified. and national security, right? There may just be information that is given to you under, you may even, if you are have an army affiliation, and we have a number of researchers with that here at SU, you may even have security clearance, and obviously you can't put stuff that that is classified into shared data. There may be some other reasons, but that kind of gives you a nice range. Oh, the other big one that's very real is it takes some time to prepare data for sharing, and the rewards aren't always huge. So that's just something to be aware of, and that's why it's good to have budgeted for the time it takes you to prepare to share the data, so at least you feel like you have gotten some grant money or whatever it is for it. But it's only fair to acknowledge that data sharing does take some time. Very briefly about ethics, right? It needs to be, if you promise someone confidentiality or anonymity, you need to respect that. If people need, if your research involves people, they need to participate voluntarily and free of coercion. You need to prevent harm among participants. It's not technically the case that it must be avoided in all instances. If you do research that has enormous benefits, typically medical research, there are certain stipulations if the expected benefits outweigh the harm, in which you can harm participants a little bit, but you must be very, very clear about those risks. If you have any conflicts of interests, those must be explicit. A lot of this can be done better if you plan for it. And that's right, Glenn alluded to this. If you write in your data management plan, for example, that you need some extra time, that's a good thing. For collecting, identifying information, often if you're worried about participants, you don't even need to know their real identities and names. So say for focus group research, that's often a good strategy to protect their confidentiality, is if you don't know who they are, it's much harder to for anyone else to find out. And if there's a legal case, you right, and you can be subpoenaed as a researcher, you don't have information that gives these people away. The other part is informed consent, right? And this is really important to think hard about as if you are doing human participant research. Be very mindful about your consent script. Often we'll find things like only I and my research team will access the information that you provide in those consent scripts. And you want to be careful in what you promise there, because it is a legally binding promise, and you can't then just go ahead and put this in a data repository, say. Think about oral versus written consent, right? This is a general question, but written consent can sometimes make research harder because it feels overly formalistic. It can also sometimes make things easier because it shows participants that you have thought and take their agency seriously. So trade-off there also dependent on cultural context. I've heard from some people that they've made much better experience with written consent, whereas I did a lot of fieldwork in Latin America where written consent in general worked not at all. And the last thing is, if you are planning to share your data, ask about this explicitly and including in your IRB application. And here's an example of a really nice where two researchers that I work with who are doing very sensitive research, so this is abortion research, have done this. So they actually give the participants agency, right? They can opt into data sharing. And if they say no, they still interview them, but they won't share the de-identified, obviously, data. And if they say yes, they will share the data. And most people actually, even with sensitive topics, say yes because they participate in the whole research exercise because they want to be useful. And then very briefly, and that's my last topic, where to share. It used to be that you saw data will be shared upon reasonable request under a lot of journal articles. You still see that. It's not good practice. It's increasingly deemed unacceptable. So you should plan on moving away from that. We also still seeing people share data on personal websites or as part of journal supplements. Neither are particularly good. Personal websites go away. Say you change institution, you stop paying your GoDaddy fees, so your website registration fees, those sorts of things. Journals actually don't take terribly good care of their supplements. They take very good care of the articles, which is why we have data repositories like QDR. And there's a range of them. Some institutions have data repositories. Syracuse doesn't, so that may be at a future place of employment, may be an option for you, isn't at Syracuse really. There are data repositories, and here are three very prominent ones that are kind of generalist and self-service, very easy to use. You put your data up there, you click a button, it's immediately published. They're very good, have lots of data, very easy to use, but you don't get any help. So if you have doubts about, how should I do that? How should I format that? Is this sufficiently de-identified? Those sorts of things, you don't get any help there. And then there are disciplinary repositories where subject specialists work and help you share the data in responsible ways. And they exist across disciplines. So I've provided some examples here and then a link to a huge list provided by the Springer Nature Publishing Company. So that would be QDR and ICPSR in the social sciences. GenBank is a popular biology one that has genetics data. Pangea is a German one that has earth science data. So you really have a wide range of options there. And I think the Springer Nature list has something like 150 or so on there. And last thing, not all data can be shared openly. That slogan is something that the EU uses in lots of their publications. You should default to open data. So there is a CC0 or public domain license that's often advocated, or CC BY. CC stands for Creative Commons. That's a family kind of copyright licenses. CC BY means anyone can use the data as long as they credit you. Where that's not possible, sometimes you can create a public use file of the data, so data without maybe a category that would make it too identifiable and could make that open, and then the other data isn't shared. You can put timed embargoes on it, typically short embargoes if you're just interested in first use. I've seen Miriam's question, I'll just finish this slide. So say 1 year or so after you deposited, maybe 3 years. Longer embargoes for human participant reasons. So you can maybe wait 10 or 100 years if you want to make sure that, say, people have left a certain institution or so before data becomes published. QDR and lots of data repositories will also take data where you need to apply to reuse it, and we then look at how do people say they're going to use it? Are they the legitimate researchers? Those sorts of things. And for the most sensitive data, there are special facilities that either you access electronically, so that's referred to as a virtual enclave, or in the most critical cases, have to go to physically to access highly sensitive data. And in many cases, then also whatever you take out of the data, so your statistical results or your notes are specifically vetted to make sure that you're not identifying anyone. So even when you share the interview without any identifying information, you should specify that in your IRB. The IRB understands that difference. You still need to go through IRB, obviously, and you will describe that you will share de-identified information in your IRB, but you can still definitely qualify, say, for an exempt category on your IRB, if that's the question, if you're using or sharing de-identified information, provided, of course, that you qualify for an exemption otherwise. And the SU IRB understands data sharing very well, so I wouldn't be particularly concerned about having to explain a lot there. They're really on top of things because they've worked with Maxwell a lot, I think. here's a couple of ways to stay in touch with QDR. If you work on qualitative social science data, more broadly on social science data, and I take this very widely, so you do anything that seems kind of social sciencey, we're happy to consult on data management plans, data sharing, whether you want to share data through QDR or not. Otherwise, probably the library. So if you're in the hard sciences, the library is probably a better place to go for advice on DMPs. I have a couple of more minutes to stick around if there are more questions, but otherwise, I know we're past the hour, so I'm happy to let you go.
If you do have a question, by all means, feel free to just unmute yourself and ask it. As Sebastian said, we are past the top of the hour here, but I just want to mention a couple of things real quickly in terms of additional resources. Sebastian mentioned the library. That is a great resource, especially the Know Your Subject Librarian. This is something that I think many graduate students don't clue into early in their graduate career. They find out later after they've already, done a bunch of work that would have been so much easier if you'd consulted with your research librarian, with your subject area librarian. So find out who that person is. One of them, Emily Hart, will be giving a presentation for the FPP on October 30th. I mentioned this at the top of the hour. That's going to be on enhancing your research reputation and visibility. Emily is the research impact lead for the library. Paul Byrne is the research data services librarian. He's a great guy to talk to, especially, for example, if you've got a project, but you're not exactly sure which of the competing data analysis collection or analysis systems is going to be the best thing for you, and many other questions. He's also very knowledgeable about the never-ending software packages that keep coming out. You may be halfway through your project and something appears. What do I do? He's a great guy who can help you work through those kinds of issues. And finally, there was a lot of questions pertaining to IRBs. The Office of what is it exactly?
I think it's research protection, right? And integrity.
Office of Research Integrity and Protections.
There it is.
Yeah, they're in the Office of Sponsored Programs. They're the ones that facilitate the IRB process at SU. Tracy Cromp heads that unit. She's another great person. Jean Ditterich in that office you could talk to get more information about the IRB process. That's another thing I see a lot with graduate students is underestimating the time that it takes to get an IRB and underestimating the amount of work that they're going to need to do in order to clear that hurdle. And often when you're planning for your degree completion, the IRB can be one of those things that makes that more challenging than you might expect. If there's interest in that topic, let me know. I might be able to set up an FPP program with ORIP for you. But those are some great resources that are available and that I find grad students frequently underutilize. We got a question in the chat. As a grad student analyzing secondary data, what would be a good way to ask for data that is already published in an article?
Ask. I mean, find the corresponding author and ask, and be very, very, very polite, especially as a graduate student. You don't want to burn any bridges. But disciplinary norms vary. So I wrote a paper with 6 secondary data sets as a graduate student, and I got all of them within a week of asking. That's kind of at the positive end of things. I would imagine with medical publications, there's a lot more guarding of data. So you might run into more resistance. And there is more of a culture that co-authorship is expected from authors who share their data, which is unheard of in the social sciences, but much more common in the medical field. So you may have to be prepared to negotiate that and then decide if you feel, if you want the data badly enough that you think that's worth it, or if you feel like that's highway robbery and you don't. So that would be the thing. But yeah, if when in doubt, let your advisor read over the email. Some people don't take these super well. So you want to be very, very polite and be clear about you know, their admiration for the work, etc., etc. All right. Thank you, everyone. And again, you can email at that email. I'm one of the people who read it if you have any follow-up questions. And I hope this was useful.
Let's take a moment to give Sebastian a round of virtual applause, please.